SwayamPrabha. Digital India. Educated India. SwayamPrabha. Digital India. Educated India.
Hello everyone, I am Dr. Manish Tripathi. As a part of this lecture of series on the subject of air transportation, today I will be delivering a presentation on the topic of air navigation, that is part 1 of the subject air navigation. The contents of this presentation are as follows. The presentation will begin by giving a brief introduction to the topic of air navigation, what are the historical aspects related to this topic, and what are the latest advancements that are associated with air navigation that has been helpful to carry out the overall navigation process for different pilots across the world. Subsequently, we will delve into the different types of air navigation processes that are being implemented worldwide, which will be firstly initiated by the visual description of visual navigation, followed by a brief description about the instrument navigation. Subsequently, after these two topics, we will be dwelling onto electronic navigation and the process that is followed to carry out safe landing. As a part of part 1 of this lecture series on air navigation, this particular presentation, the presentation today will be basically related to covering the first 3 topics, that is introduction, visual navigation and followed by instrument navigation. So, what is air navigation? As the name suggests, navigation basically corresponds to the term which will determine the process that needs to be followed so that a particular person can reach from point A to point B. Let's understand this with an example. Suppose a pilot wants to reach from point A to point B. Based on different consideration, external consideration, aircraft operationability, as well as the airspace constraints, the pilot will determine the most optimal route between the point A and point B. Air navigation basically entails the different techniques that are required to be followed during the flight so that we can reach our destination via the predetermined flight path. This particular process also involves regular monitoring as well as controlling the plane so that the destination can be reached with the minimum amount of time and fuel consumption while covering the predetermined waypoint points. The pilots, as a part of this overall air navigation process, the pilots, whether be flying through the visual navigation or via the instrument navigation, they need to file a particular flight plan to the nearest ATC before the departure. So, in order to understand any topic, we need to understand what has been the historical evolution of that topic. Ascertain that this particular slide will cover different aspects related to the development of air navigation throughout history. The history of this evolution can be divided into the following subcategories. During the advent phase, that is during the 1900s to the 1990s, Most of the air navigation was carried out through the usage of visual markers. Visual means through the reference to the horizon. So what the pilots would do, the pilots would basically make use of the visual aids that are available at the pilot's disposal to carry out the navigation. Subsequently, as the need arose to carry out air mailing, which required the flight to be operated in the night conditions, a number of additional techniques were integrated across different airports. For instance, many of the airports made use of lighted runways, beacon airways, bonfires, as well as low frequency radio range communications. Subsequently, in 1927, the most famous flight by Charles Lindbergh in May 1927 was one of the cornerstones of air navigation and development. In fact, this 33-hour flight between New York to Paris was the turning point in aviation. The difficulties that were faced by Charles Lindbergh during his transatlantic flight was pivotal in determining the overall development of air navigation. In fact, this flight proved to be so crucial that this particular time is termed to be as the Lindbergh boom, which resulted in a significant increase in interest towards aviation as well as development of various air navigation technologies. Based on the requirements that were there to increase the communication between improve the air navigation technologies and the air radio navigation technologies, many other techniques like the non-directional beacons and ADF, that is automatic direction finders, were integrated on the various aircrafts to carry out the navigation. Subsequently, the 1950s to 1960s era belonged to the evolution of VOR and DME as well as ILS technology, which were more advanced air navigation techniques to carry out more precise navigation. The 1970s and 2000s, between 1970s and 2000, the aircraft industry basically ventured onto new techniques of air navigation, that is INS and GPS. Through the integration of these sophisticated technologies, navigation was not just limited to the line of sight range. In fact, navigation could be carried out through transatlantic regions also because of these technologies. As the technology further evolves, the 21st century is poised to implement more automated ways of carrying out air navigation. So most of the operations associated with navigation, like communicating between the ATC or vice versa, and also checking the waypoints, checking the overall route, trueness of the route being followed by the flight, they will automatically be carried out by the onboard computers. After carrying out understanding what has been the historical evolution of air navigation, we need to understand what are the various factors that determine the air navigation planning. So air navigation, which entails the process of reaching from point A to B, is a process that needs to determine the most optimum route between A and B, so that minimum amount of fuel and time is consumed during the flight. This particular planning or the route that is being decided by the pilot is dependent on a number of external factors. Some of these include the planned route should conform with the laid down ICAO standards, ICAO rules, as well as the compliance with the latest ATC instructions related to that route. The route should be planned in such a way that the fuel consumption as well as the time is mitigated as much as possible. The route should be planned in such a way that a minimum safe distance is obtained with respect to the neighboring flights as well as the underlying airspace considerations. The airspace consideration, we will be discussing about this particular aspect in a later slide. So one of the most important parameters related to air navigation planning is what are the available facilities and the airways that are available to the pilot, so that flight planning is carried out in a more efficient manner. So after going through the factors that affect the overall air navigation planning, we need to understand what are the objectives of any air navigation process. First and the foremost objective related to air navigation is what is our current location. Based on determination of the current location, we need to understand what would be the nearest waypoint associated with our planned route, and what is the optimum route between the two waypoints, so that minimum fuel and time is consumed during this particular planned route. So in order to achieve these objectives, there are many other external considerations that we need to take, that the pilot need to consider while carrying out the flight planning. Some of these external factors include the presence of weather, that is whether the planned route has any hazardous weather associated with this. Based on presence of such hazardous conditions, weather conditions, the pilot needs to readjust their planned route. Second parameter related to this air navigation is the aircraft performance. So as we all know, with advancement of time and with the increase in operational cycle of any aircraft, their performance goes on reducing. So the planning needs to consider this factor also to carry out the planning. The airspace requirements, as we have covered, as the air transportation course covered during earlier lectures given by Professor Rajkumar Pant, there are many airspace constraints that are related to any air traffic management service. So while carrying out the air navigation planning, such considerations or constraints need to be taken into consideration. The terrain underlying the planned route also plays a very critical role in carrying out the overall flight planning. Last but not the least, the applicable rules that are associated with the planned course as well as the planned way of navigation also plays a critical role in carrying out the overall air navigation. So based on all these aspects and based on the aircraft performance, what are the applicable facilities and what are the instruments that are available to the pilot, there are two different types of rules by way of which the pilots operate their flight. These two rules are called the visual flight rules and the instrument flight rules. The visual flight rules, which is the most rudimentary form of air navigation, is purely based on visual flight navigation. So the pilot basically makes use of the visual references that are available to the pilot during the daylight and in weather conditions, and so basically the pilot makes use of the natural horizon that is available to the pilot, and the external visible outside reference is carried out during the flight to carry out the overall navigation. This type of navigation requires a number of key components to carry out an efficient navigation. These components are the overall flight planning. So as I mentioned to you earlier, all the air navigation requires filing of a particular flight plan to the nearest ATC before the commencement of the flight. Then the visual flight rule navigation basically makes use of aeronautical charts during the pre-flight as well as on in-flight scenarios to carry out the planning. The two methods that are used to carry out this particular navigation are called the pilotage and the directing. Details related to these two methods will be dwelled into in the later slides. So based on this, we can determine what are the different prerequisites of any VFR flight. So if you are planning to carry out any VFR flight, you need to have these three components with you always. First and the foremost, flight plan. This flight plan is designed or is designed by the pilot before the flight. The planning is overall dependent on the what is the fuel consumption requirement and what are the waypoints that the pilot will intersect during his flight. what the second component of the VFR flight are the aeronautical charts, and the third and the one of the most important prerequisite are the weather forecast. So as far as the flight plan is concerned, in order to understand this, I have brought to you, I will put forth towards you a particular example of a flight plan. In this flight plan, as you can see, this flight has been planned between so this flight is supposed to happen between Bangalore to Mumbai, and the overall flight plan includes details related to what are the waypoints that the flight will follow, will intersect during the flight, and minute details related to what are the related to the aircraft, what would be the true airspeed and the ground speed, what are the flight levels that the plane will follow during the course, and what are the external wind conditions associated with the planned flight. Subsequent to this, the flight plan further includes details related to what are the fuel consumption that the plane would incur during the different courses of flight. So the flight plan overall plays a very critical role in carrying out any visual flight route navigation. After carrying out the flight plan, filing the flight plan, the pilots need to make use of aeronautical charts to carry out navigation. These aeronautical charts are basically specialized maps that are used by pilots to carry out navigation. These plots are maps that include different terrain features like topographical features associated with the particular area being flight in, what would be the applicable hazards and obstructions associated with the route, the navigation routes and aids that are available at the pilot's disposal, what are the applicable airspace rules, and what are the airports that are available for the pilot to land upon or use the facilities from. So these aeronautical charts are of different categories. Most of the visual flight rule navigation make use of a particular category of aeronautical charts, which are called the sectional charts. These 1:50,000 aeronautical charts or the sectional charts are used comprehensively by the pilots to carry out visual flight navigation. Let's understand what are the different components of any aeronautical charts. For instance, in this particular chart, you can see the circled part is basically a runway. This is accompanied by the description related to this airport. For instance, in this case, this is a Nashville International Airport with a control tower frequency of 108.6. So there are many other details that are embedded inside this aeronautical charts. For example, there are details related to what are the obstructions associated with this sectional chart. And what would be these circles are basically describing what are the airspace. For instance, in this case, the solid magenta line basically corresponds to class C airspace, and the dotted circles are basically class D airspace. So these sectional or aeronautical charts play a very critical role in carrying out the overall air navigation process. In order to assist in carrying out the overall flight planning, all these aeronautical charts are accompanied with the appropriate legend, so that the appropriate flight planning can be carried out based on referring to these legends. World aeronautical charts are basically a subcategory of aeronautical charts. These are scaled by 1:1 million. Because of the increased scaling, most of the features related to the control towers and minute obstructions are hidden. However, these charts had been used previously for long distance flights by different flight applications. The third important prerequisite of any VFR flight is the weather forecast. So before commencement of any flight, the pilots need to carry out a thorough evaluation of the weather forecast associated with the airport of departure as well as the airport of destination. Also carrying out understanding the weather forecast associated with the planned routes, so that on-course planning can also be carried out. For instance, in this image is basically related to an anemometer. This anemometer is installed on various airports. Through the usage of this instrument, the overall wind direction and wind speed is measured, and this is through these measurements a weather forecast associated with the different regions is provided to the pilots. Based on these forecast conditions, the pilot will carry out his flight planning and include those relevant details in the flight plan log also. So what are the two methods of visual navigation? So we want to reach from point A to point B. We can carry out visual navigation through the usage of two methods while covering the different waypoints. These two methods are basically called pilotage, and the second method is called the dead reckoning method. What is pilotage? Pilotage is basically the most basic form of visual navigation, which makes use of visual aids and markers as well along with the aeronautical chart to carry out the navigation. How does this work? Let's understand this with an example. Suppose a pilot wants to reach from point A to point B. He will select two different towns annotated as waypoint 1 and waypoint 2. So when he selects these waypoints, he wants to have a particular obvious visual reference which the pilot can follow during his flight, and he can ultimately reach his destination. So based on these waypoints, he will plan his route and also follow these waypoints to carry out this navigation. Despite carrying out the planning, regular adjustments are required to be carried out during the flight, so as to mitigate the deviations that arise because of the external environmental conditions. The external conditions that basically are related to these deviations arise due to the presence of crosswind conditions. So the inclusion of crosswind condition and the applicable corrections that are required to carry out the air navigation plays a very critical part of the overall pilotage process. So in case of the presence of any wind conditions, the pilot needs to adjust his heading according to the external wind condition so that the true course can be efficiently followed. For example, in this particular case, the wind is coming from the left, so the pilot needs to adjust his heading towards the right so that the overall deviation towards the left can be mitigated and the true course can be followed by the plane. The second method of visual navigation is called the dead reckoning method. So how this differs from pilotage? It differs from pilotage in the sense that it along with heading calculated by by compass and speed determined by the airspeed indicator, this process brings into picture the time aspect also. So the pilots majorly make use of a combination of pilotage as well as dead reckoning to carry out their navigation. This particular method is subsequently carried out to calculate the overall deviation that the flight has incurred during the flight how this is done. For example, if the pilot has planned to follow a particular course from point A to point B, he determined his location at a point at 1000 hours. After 10 minutes, that is at 10 hours, he determines that the position has changed to a particular reference point which he has logged. After 10 minutes, then after 10 minutes, he will again determine what is his current location. So based on time, speed and heading and the usage of proper trigonometry, he can calculate what with the applicable heading that the pilot needs to adjust his plane to, so that the true course can be intersected. So this is the overall process of dead reckoning, wherein time also comes into picture. One of the most important aspects related to dead reckoning is the wind triangle. What is this wind triangle? Wind triangle is a mathematical tool that is used comprehensively by pilots to carry out different aspects related to a flight. For instance, through the usage of wind triangle, wind correction angle can be determined, so that the overall heading that the pilot needs to follow can be determined. The wind triangle can also be used to calculate the drift. So, for example, during a flight, the pilot determines that the plane has drifted away from its planned course. Through the usage of this wind triangle, the overall drift of the particular plane can be determined. Based on this wind triangle, the overall ground speed as well as the heading to maintain the true course can be obtained, and based on these calculations, the overall time that the pilot would incur to reach the destination can also be obtained. So in order to understand this wind triangle, there are two different methods that I have presented in this presentation. Method A, in method A, for example, we know the airspeed that the flight will follow, and what is the true course that the plane needs to follow to reach its next waypoint. For instance, in this case, the length of this line is not yet determined. Then based on our weather forecast, we know what is the applicable wind conditions. For instance, in this case, a wind from left side is coming at a speed of 20 knots from a direction of 30 degree. The length of this particular line will be based on the scaling of the speed. So, for example, in this case, every knot will correspond to 1 millimeter. So this particular line, blue line, is a 20 millimeter line corresponding to a wind speed of 20 knots. So from the head of this wind direction, a line will be drawn intersecting the true course line in such a way that the length of red line would correspond to an airspeed of 110 knots. So based on this calculation, we can determine what is the wind correction angle that will be required to follow the particular true course. So then the other method, that is method B. In this method, we firstly draw a line of 100 corresponding to 110 knots related to a true course of 90 degree. Suppose we know a wind speed of 20 knots coming from port direction from a direction of 30 degree. The line that joins from the head of the true course line to the wind direction will be ultimately useful to carry out the overall drift. So both these methods can be used on the different conditions that are prevailing. The method A can be used to determine what is the wind correction angle during the pre-flight phase itself, whereas the method B can be used to determine what is the applicable drift, so as to determine what is the deviation that the flight has incurred during the flight operation. As you noted till now, this is a tad difficult. So in order to difficult during the overall flight operation, in order to circumvent this problem, pilots during their visual flight make use of a particular computer called the E6B computer. So all these calculations that are showed to you previously, those all have been integrated in this particular E6B computer itself. So visual navigation, as far as the instruments related to visual navigation is concerned, there are two important instruments that are used to carry out such navigation. These two instruments are called the magnetic compass and the heading indicator. What is magnetic compass? magnetic compass is based on a simple principle of magnetism. So as many of the viewers might know, a magnetic compass basically works on the fact that whenever you place a magnet, it always aligns with the north-south direction. Based on this principle itself, the magnetic compass operates. So in this particular figure that you see, this is a magnetic compass which is fixed, embedded inside a liquid, and based on the magnetic orientation of the true magnet and true south, the overall magnetic heading of the aircraft can be determined. So a point to be noted here is that these instruments always point towards the magnetic north pole, and based on this the overall heading that is shown by the instrument is a magnetic heading reading, whereas the aeronautical charts that are implemented to carry out the overall flight planning is based on the true north. So here lies the ambiguity. There is a difference between magnetic north and true north. Why this difference arises? This difference leads to the formation of a new term that is called the variation. This difference, which is basically the difference between the true north and the magnetic north, is a very important aspect of carrying out navigation using the magnetic compass. Why this variation basically arises? For instance, we all suppose there is a line joining true north and true south. Ideally, the true magnetic north and magnetic south, if they were aligned with each other, this type of variation would not arise. But the magnetic meridian, that the line or the great circle that passes through the magnetic north and the magnetic south is not aligned with this true meridian. So for instance, the magnetic north is located somewhere in the northern Canadian region, and so because of this difference, the difference between this true north and true south line with respect to the magnetic north magnetic south line is called the variation angle. Now this variation angle depends on aircraft's current location and time. So if you're thinking that magnetic variation would be overall same at all different locations, it is not the case. It varies from location to location and as well as from time to time. So in order to determine this, the pilots make use of the azogonic line charts. So as you can see in this figure, this is a brief representation of the variation at different locations of our Earth, and the lines joining similar variation are called the isogonic lines. The lines which join variation of corresponding to 0 are called the agonic lines. So these charts are basically used by the aviators or the pilots to determine the overall variation angle. The other variation disparity related to magnetic compass readings are called the deviation. So why these deviations arise? These deviations arise because of the interference of external electromagnetic fields with the compass operation. In order to determine this value during the flight designing itself, cockpit designing itself, the engineers determine what are the applicable deviations that arise because of the presence of these electromagnetic fields, and these are presented to the pilots in the form of a deviation magnetic deviation card. During the calculation process, the pilots refer to these deviation cards to carry out the overall calculation, so that the actual compass heading that the pilot needs to follow is determined accurately. So based on these corrections that are required to the compass heading, the pilots firstly make use of, as we determine, the pilots make use of magnetic compass while navigating, and in order to carry out this navigation in an appropriate and efficient manner, the pilots need to implement these variation and deviation angle into the overall calculations. And based on these calculations, the pilot will follow the overall compass heading, which is the actual heading that the pilots need to follow, so that the planned course can be followed. So let's understand this with an example. Suppose a pilot has determined a particular course that he needs to follow to reach a particular waypoint. This true course is based on the true north. This is called the true course. This true course based on the external wind conditions, and while implementing the wind triangle, the pilot can determine what would be the applicable wind correction angle, and integrating this wind correction angle, the pilot can determine what is the true heading that the pilot needs to follow. Now this true heading includes deviations arising due to the different magnetic compass readings. Firstly, the variation angle has to be integrated. Based on this correction, the overall magnetic heading can be determined. After carrying out addition and subtraction associated with the deviation, the overall course heading can be determined, and this is the final course heading that the pilots will refer to in his during his flight to carry out the particular navigation. So apart from the variation and deviation angles that the pilot needs to consider while carrying out navigation using the magnetic compass, there are some other errors also associated with this type of navigation. Some of these errors arise because of the presence of acceleration. So this type of error basically arises when the plane is flying in a east-west heading. So whenever an aircraft accelerates, the compass will point in a more northerly direction, whereas if the plane deaccelerates, it will point in a more southerly direction. In order to memorize this, there is a particular acronym that pilots use, that is the ANST, to determine the overall error associated with acceleration. The other errors, apart from acceleration, there are also errors associated with the turning. So these type of errors occur when the plane is flying in a north-south heading. So if a plane tries to turn while carrying out a northern heading, the compass will show a slow rate of turn, whereas when a plane tries to turn while flying in a southern direction, the compass will show a more exaggerated form of rate of turn. So in order to memorize this, the associated acronym is NOS. So apart from the acceleration and turning errors, there are many others errors associated with the presence of electromagnetic fields or the magnetic or the errors associated with presence of magnetized object that can create local magnetic fields and thus create errors in the overall compass heading readings. So as I pointed out, there are many errors that are associated with magnetic compass heading readings, and there are many calculations that need to be integrated while carrying out the overall flight planning. So in order to reduce these problems, pilots started making use of another instrument to carry out visual navigation. This instrument was called the heading indicator. This heading indicator is basically also called the directional gyro, and is used to determine the overall aircraft direction to aid the pilot in carrying out the air navigation. From a procedural point of view, the pilots before the commencement of the flight, the heading indicator needs to be calibrated so that the heading indicator will be showing the accurate heading value. So as the aircraft turns, the heading indicator rotates, constantly displaying the current heading. So as you can see in this particular figure, whenever the aircraft turns, the overall aircraft will remain static, but the dial will change. Based on the change of this dial, the pilot can determine what is the overall heading that the plane is being flown upon. As I mentioned to you, these heading indicators are basically based on the principle of gyroscope. Now what are these gyroscopes? Since this is not a mechanical lecture, I will just briefly tell you about this, but directional these gyroscopes. These gyroscopes are basically mechanical systems which include a central rotating mechanism which is surrounded by the external gimbals. Now this rotating mechanism has the feature of staying in its rotational axis, whereas the external gimbals are free to rotate about its axis in any particular direction. So based on this particular principle, these gyroscopes operate. The overall instrument is designed in such a way that the static direction is aligned with the rotating disc, and based on this reference, the overall orientation with respect to that static axis can be obtained, and thus the overall deviation can be determined. So because these are not dependent on the magnetic fields, the overall errors that were associated with magnetic compass don't come into picture with respect to heading indicator, and hence moreover the acceleration and turning errors associated with heading indicators are negligible. Despite these advantages, there are some other underlying disadvantages related to heading indicators. Some of these include the fact that these are based on mechanical systems. They are always prone to internal bearing. Because of the presence of such wear and tear and internal bearing issues, the heading indicators slowly drifts away from the actual value, and hence these need to be regularly tuned. The second error associated with these instruments are the presence of precession. So as you can see in this, just like a top, as the time progresses, these gyros tend to precess in a particular direction, and hence these require regular fine tuning so that the indicated heading is accurate. So what is the overall VFR process? First, based on our flight planning, we determine the true course. Now this true course is based on minimizing the fuel as well as the time constraints. Subsequently, based on this true course, we log this in our aeronautical chart. Now this aeronautical chart will be available to the pilots during the flight phase also, to carry out the reference process. Based on this true course and the overall applicable variation and deviation, the overall true heading that the plane needs to follow will be determined, and after carrying out this planning, in-flight corrections are also required based on pilotage and dead reckoning, so that the planned course can be followed in a more efficient manner. Despite carrying out all the planning in an efficient manner while including corrections associated with the magnetic compass, deviation, variation as well as wind correction angle, there are many drawbacks associated with visual flight navigation. So the most prominent drawback associated with visual navigation are the drawbacks that the pilots the difficulties that the pilots will face while carrying out visual navigation when the plane flies in night conditions or bad weather conditions, or while carrying out flight operations in a sparsely operated regions. All these flight conditions would make it impossible to refer to any visual aid, or also refer to the horizon. So because of the presence of these conditions, visual navigation will be very difficult. So in order to mitigate these problems, there have been many measures that have been taken out. For example, night condition operation has improved because of the integration of runway and airport lighting. as well as airway lighting. So what are airway lighting? Airway lighting technologies were erstwhile implemented across various airports in the USA. So what these airspaces included was that these were these airspaces, these airways made use of 51 feet towers. Atop these 51 feet towers was placed a beacon, and these beacons were coded in a way so that which would be through the reference of which the pilot could determine what is the type of airport or the waypoint, and also whether the plane is going towards or away from the waypoint. So these are some of the measures that were implemented erstwhile by airports all across the globe, especially across USA, to mitigate problems associated with night flight operations. So despite these measures, there were still unavoidable circumstances or hindrances associated with visual flight navigation. For instance, if the flight was operated in a condition related to cloudy conditions or bad weather conditions, the reference to visual aids or beacons was hindered, and hence visual references could not be established, thus making the visual navigation an onerous task. So in order to circumvent this problem, the pilots started venturing onto a different mode of navigation, and this type of navigation was called the instrument flight rule navigation, or famously acronymed as IFR navigation. These IFR navigations this type of navigation made use of a number of instruments to carry out the navigation. So as the aircraft design and instrumentation technology evolved, the pilots were able to make use of just the pilots were able to control their flight and carry out the navigation just through the reference of their cockpit navigation. Hence, visual reference to natural horizon was not a mandate, and hence navigation could be carried out through the uses of these in-flight instruments itself. So these the most notable feature related to these instruments was that these were based on gyroscopic principles, which made the pilots made it possible for the pilots to control their aircraft without reference to the natural horizon. So the most notable instruments that have been used worldwide to carry out such navigation are called the six-pack instruments, as you can see in this particular figure. These six-pack instruments are the most important aspect of instrument flight navigation. The different six-pack instruments that are used worldwide are as follows. The first attitude indicator is basically this particular instrument basically mimics the overall attitude of the aircraft. So as you can see in this particular figure, the overall location of this artificial aircraft will determine with respect to the natural horizon will determine what is the overall attitude of the aircraft, and also based on reference to this particular instrument, the pilot can adjust their flight attitude and keep the aircraft upright and under control. Based on reference to this particular instrument, the pilot can determine whether their aircraft is banked or in a pitch motion, whether it's pitching up or pitching down. So for example, in this particular figure, the aircraft is oriented in a pitch up direction. In this orientation, the aircraft is oriented in a left bank condition, whereas in this it is oriented in a bank right orientation. So through this instrumentation, the pilots can very easily determine what is the overall attitude of the flight. Then the other six-pack instrument is called the heading indicator. As I already mentioned to you, this gyroscope principle based instrument is a very efficient way of determining what is the overall direction of motion of the aircraft. The third instrument, that is the turn and bank indicator. Now this instrument is basically used to determine what is the direction and rate of turn of the overall aircraft. For example, in this particular figure of yours, the pilot can determine that the plane is banked in a right turn direction. In this particular figure, the plane is oriented in a left bank direction, whereas in this through the deviation of the ball that you can see in this particular image, the pilot can determine whether the plane is in a skid motion or not. The fourth and one of the most important parameter instrument related to instrument flight navigation is the altimeter. So the altimeter basically based on the principle of static pressure evaluation determines what is the height of the aircraft with respect to mean sea level in feet. There are three different dials associated with this, that is corresponding to 100 feet, 10,000 feet as well as 1,000 feet pointers. Now these altimeters have to be adjusted throughout the flight based on the prevailing flight conditions, and hence is a very important aspect related to instrument flight navigation. The fifth six-pack instrument is called the airspeed indicator. Now this instrument is used to determine the overall airspeed of the aircraft. Now why airspeed is important? Airspeed will determine what is the overall fuel consumption and the time consumption associated with your flight. Moreover, the determination of the airspeed also determines what is the speed, whether your plane is flying in a speed that is in an operational range or a critical range. So airspeed indicators entail a number of visual indicators to determine. For example, the green part of this airspeed indicator determines that the flight is being operated in a safe region. The yellow is a caution speed region, and the red marker determines that the speed has exceeded the maximum safe operation. So airspeed indicator also plays a very critical role in carrying out the air navigation. The last important six-pack instrument is called the vertical speed indicator. So based on the principle of determining the difference between static pressure at different altitudes, this particular instrument determines what is the overall rate of descent or ascent of the aircraft. How this is helpful? The overall rate of descent or ascent would also govern the applicable structural constraint, and hence the flight needs to be ascended or descended in a particular rate only, so that structural constraints are not compromised. So in conclusion, we can say that air navigation is a very key part of safe and efficient air traffic management. Air navigation, by way of carrying out proper flight planning, safe operation of any aircraft, while considering the applicable fuel and time consumption time penalties. Navigation can be carried out in two ways, that is instrument flight rules and through visual flight rules. VFR is the most rudimentary method of air navigation, which makes use of magnetic compass to carry out the VFR navigation. VFR also makes use of two important methods, that is pilotage and dead reckoning, to carry out on-course flight planning. The second method, that is instrument flight rules, make use of the six-pack flight instruments to carry out the navigation. Now when I say six-pack instruments, these are not the only instruments that are used, but they are the most important aspect related to any IFR based air navigation. So In the next slide, we will cover different aspects related to electronic navigation. What are the different radio navigation aids that are implemented by aircrafts throughout the world to carry out the navigation, and what are the different drawbacks associated with different air navigation processes. See you later. Bye-bye.